Hello, welcome to lecture 3. Today I will talk some exercises on triangle which are from your textbook. These exercises are given in your textbook. So this is a mathematics for class 9 based on NCERT syllabus. My name is Sangam Banerjee and the details are given below. So this is exercise 7.1.2. Just go through this. If you have a quadrilateral ABCD, is a quadrilateral, that is 4 sides A, B, C, D, and has 4 angles. We will deal in next chapter quadrilateral. Okay, we will introduce because triangles are involved in this quadrilateral, in which this AD is equal to BC. So I mark 2 dashed lines. So these lines are AD is equal to BC is given. And angle DAB, this angle A, is equal to angle CBA. Okay, this angle B. This center one is angle A here, and this center one B is angle B. So these two angles are same. So prove that triangle ABD, this triangle marked in hash, is equal to triangle BAC, and prove that this diagonal BD is equal to diagonal AC, and also prove that angle ABD, this ABD, this angle is equal to angle BAC. Okay. So before going to the proof, let me give you some idea. Suppose this is a line AB, and with this line I have two arms AD and BC, say of equal length. So when this moves, okay, this I can move this also with equal angle. I can bring it here. Okay, this is your acute angle, this is your obtuse angle. So if you join, and they are same angle, so if you join this diagonal, you feel it has to be same, isn't it? You feel it has to be same. Suppose here also for this I put up a diagonal. So this two triangle, this triangle and this triangle appears to be same, but we have to prove it. Okay, just in mathematics you have to prove, not feelings are not so important. So let us try to prove the first part. So triangle ABD and triangle BAC, side AB, this side AB. So these two triangle both has side AB. This triangle also and this triangle also have common side. And angle A, this angle A is equal to angle B. So I have one side, one angle, and side AD is given, AD is equal to BC. So from side, angle, side, I can say this triangle, your ABD is congruent to triangle BAC. Okay, from side, angle, side. Second, since it is congruent, for a congruent triangle, all side will be same, isn't it? If you prove from side, angle, side or angle, angle, side, then automatically you will see, once you say congruent, by definition of congruence means all sides, respective side, corresponding side. Okay, CPCT, when we say corresponding part of congruent triangle. So these are the corresponding parts. So BD equal to this BD equal to AC from CPCT. And because these are congruent, ABD, this triangle, because they are congruent, it implies angle ABD is equal to angle BAC. This is also from CPCT. Okay, now let us go to next exercise. Exercise 7.1.7. I am not going to do all the exercises, but most of the difficult exercises I am tackling. Okay, so once you know the idea, you can tackle the other ones also. So I am just trying to, because this is a quick way, I want to teach you all maths for standard 9. So I may jump little bit. So you please fill in the gaps. Exercise 7.1.7. AB is a line segment. This AB is a line segment. It says, this is given. And P is its midpoint. This is a midpoint. And D and E are the points on the same side, upper side, same side, okay, of AB. Okay, D and E are the points on the same side of AB, such that angle BAD is equal to angle ABE. That means this angle is equal to this angle. It's given. Okay. And angle EPA is equal to angle DPB. This is also given. Okay. This angle is equal to this angle, and this angle is equal to 1 dash, 1 dash, 2 dash, 2 dash. Okay. So show that triangle DAP, this triangle mark in this hash, this vertical hash, and this slanted hash, this is another triangle. The triangle DAP is congruent to triangle EBP, and show that AD, this AD is equal to BE. Okay. To show that triangle DAP is congruent to triangle EBP, okay, this is for triangle DAP I am writing here. So this is given angle DAP, this DAB is same as DAP, okay, same angle. So angle DAP is equal to angle EBP, this is given. And side AP is also given, is saying that it's bisecting middle point. So this side is also this side. And angle APD, okay, and BPE, this is also given. So from angle side angle, I can say triangle DAP is congruent to triangle EBP. And similarly, these triangles are congruent. From CPCT, I can say that AD is equal to BE. Okay, that is AD is equal to BE. Okay, now exercise 7.2.1. It says this is a problem given in an isosceles triangle ABC with AB equal to AC, isosceles triangle. So this AB equal to same side, so I have marked by 2 dash. So if it is an isosceles triangle, then this angles will also be same. We have seen it. The bisector of angle B and angle C intersect. Suppose I draw a bisector, is given there, and this bisector, angle O, this one will intersect, and I call it O, and then join A to O and show that OB equal to OC and OA bisects angle A. So how do you find OB equal to OC? So we have to show that this is isosceles triangle. So if these angles are same, so this becomes isosceles. So if it is isosceles, then of course OB equal to OC. This is one. And OA bisects angle A. This OA will bisect. So if we can prove that this triangle and this triangle are same, then from CPCT I can say that this angle is equal to this angle. So it bisect. Okay, half of this, half of this. So let us see how do you prove it. What I have said, you have to write it down. So given AB equal to AC and angle ABC is equal to ACB, this is given. Bisecting angle B and angle C gives angle OBC and angle OCB. Okay, and in triangle OBC, this OB equal to OC because these two angles are same. So opposite side of the opposite to the angle, the side opposite to this angle and side opposite to this angle. Since the angles are same, the sides has to be same. So by sides opposite equal, angles are equal. So OB is equal to OC. And we have to prove that OA bisects. So if AB equal to AC, since isosceles, and this side is this is a common side, OA equal to OA, and OB, this is OB equal to OC. So this is from side. Okay, so from side, triangle AOB is congruent to angle triangle AOC. So from CPCT, okay, since these are congruent, from congruence corresponding part of congruent triangle, this angle has to be equal to this angle. So angle OAB, okay, OAB equal to angle OAC. Okay, now exercise 7.2.6. It says triangle ABC is an isosceles triangle. This is an isosceles triangle ABC. That means two sides, this and these are equal. I have marked by 1 dash. So if these are isosceles triangle, then this angle opposite will be also same. So I label that label it as X, in which AB is equal to AC and side BA is produced to D. Here I am taking it from your textbook. Produce means extended to D, such that AD is equal to AB. Show that angle BCD is a right angle. So how will you go about doing it? See, here you can sum of all the interior angle of a triangle is equal to 180. That we have proved it. So what is sum of all the interior angle? Is x plus y plus x. This is x plus y. Okay. So it's 2x plus 2y. So I can say it is twice of x plus y. X plus y is what? X plus y is angle C. So twice of angle C equal to 180 degree. So angle C has to be 90 degree. Okay, divide 180 by 2. So angle C is 90. So how do I go about proving it? Is what I have said, you have to write similarly. So angle B is equal to x, angle D I call it y, angle C is x plus y. So I write angle B plus angle C plus angle D as angle B is x, angle C we have to find that is 90 degree, and angle D is y is equal to 180. So angle B is x, angle C, so twice angle C is 180 degree. Okay, angle C is x plus y. X plus y is angle C, so angle C plus angle C twice. So angle C is 90 degree. So angle BCD is 90 degree. So it is a right angle triangle. So now exercise 7.3.1. What it says? Triangle ABC and ADBC are two isosceles triangles on the same base BC. Okay. This is base BC. Same base. Okay. ABC and DBC. Okay. And DBC on the same base. And vertices A and D, this A and D are on the same side of BC, are on the same side, upper side of BC. If this AD is extended to intersect BC at P, show that, okay, triangle ABD is congruent to triangle ACD here, and second is triangle ABP. Okay, this triangle ABP is equal to triangle ACP. Okay, this triangle. Okay, and AP bisects angle A. So we are getting hint, you see, as well as angle D. And AP is perpendicular bisector of BC. This is what we have to prove. So this is also very simple. So first is we have to prove that ABD is congruent to ACD. So you are saying is isosceles. So this side is equal to this side, and this side double dash I put. This is also double dash. So they are also of same length. Okay. This is a common side. Okay. So you see here you have this side, side. So from this side, you can always say that this triangle is equal to this triangle. So ABD is equal to ACD from side congruence true. So if this is true, then from CPCT, angle 1 is equal to angle 2, because these are the congruent part. AP is a common. This AP is a common to triangle ABP and triangle ACP, and also BA is equal to CA AC. So this is a common part, this is a common part. I have said angle 1 equal to angle 2 from here. So then again from side, angle, side, these two triangles are congruent. So we have proved the second one also. Let us prove the third one. This triangle BDP, this triangle BTP is congruent to CDP. Again, I can say that this is angle, side, or some people call it side, angle. Okay. we have done that. From that angle side rule, okay, this is congruent because it's similar angle, same side. So then if it is congruent, then angle 3 and this angle 4, so it bisect angle D also. Angle 3 is equal to angle 4. Okay. So here I have done some cancellation and just go through it. You pause and go through it. And AP, third one is over. AP bisects angle A as well as angle D. Okay. And AP is a perpendicular bisector of BC. So this is perpendicular. So if this angle and this angle is same, and this sits on a right angle, this straight line, so this has to be, this straight line means what, total this semicircle or whatever is 180 degree. So and both angle is same. So this should be 90, this should be 90. So this is a perpendicular and it is bisecting. So it's a perpendicular bisector. Okay. So this is what I have written here. Just go through it. Okay. I'll not go through detail. Just pause it and see what I have written. Now exercise 7.4.2. What it says, side AB and side AC of a triangle ABC are extended to point P, this triangle ABC. AB and AC are extended to point P and point Q respectively. Also angle PBC, this is small, less than angle QCB, show that AC is greater than AB. This is given. So this I call, say, angle X, and this is PBC is smaller than BCQ, and I call it X plus some delta more. So if you see, this is X, this is higher angle. Okay. So that means this is a bigger, so this 2 will be, angle 2 will be smaller than angle 1. Okay. So since this angle 1 is greater, so this side will be greater, AC opposite, which we have proved it. And this is smaller than 2, so this side will be smaller than AC. So that's what we have to prove it. Okay. Just go through it carefully. So angle PBC, I have written angle PBC is less than angle QCB. And angle PBC is what? This is a exterior angle of this triangle here. Exterior angle X. X is angle 2 plus angle 3. Okay. We have to go back and see it. Exterior angle is sum of opposite two internal angles. These are opposite. So L2 plus L3 is less than angle QCB. Angle QCB is, this is sum of angle 1 plus angle 3. This angle 3 cancels, so angle 2 is less than angle 1. Exterior angle property I have used. Angle 2 is less than, so AB is less than AC. This is the projected length by the angle. So if this angle is small, the projected length will be small, and if this angle is large, the projected length will be larger. Okay. And this theorem is the same thing what I have said here. If you have forgotten, an exterior angle of a triangle is equal to the sum of two interior opposite angles, which I have used here. If this is A, this angle has to be 180 minus this. So this is the exterior angle. So this angle is equal to angle B plus angle C. So here we know from sum of all the interior angle of a triangle, angle A, angle B plus angle C is 180. Okay. So I take this as 180 minus A. So this 180 minus angle is this one. So this angle is sum of angle B plus angle C. Okay, now let us summarize what we have done so far. So what I thought the best is to take the summary from your textbook and present it to you, so that at least we will get confident, yes, we have covered this portion. So this is the summary of chapter 6. The first point, if a ray stands on a line, then the sum of two adjacent angles, so form is 180, which we have shown it. Okay, and this property is called as a linear pair axiom. So they are called the linear pair. Okay, if two lines intersect each other, then the vertical opposite angles are equal. This also two line crossing. Okay, and the angles opposite to each other are equal. You go back and see it. If a traverser intersect two parallel lines, then the traverser, there are two parallel lines and traverser intersect both of them, then pair of corresponding angle is equal. We have shown that each pair of alternate interior angle is equal, and each pair of interior angle on the same side of the traversal is supplementary. That is, those two angle, okay, this pair of angle, when you add them, it will be 180 degree. You go through it. We have covered all this. If a traverser intersect two lines such that either any one pair of corresponding angle is equal, or any pair of alternate interior angle is equal, or any pair of interior angle of the same side of traverse is supplementary, whatever I have said, then the lines are parallel. So if the lines are parallel, this is true. If these are all true, then the lines are parallel. Okay, lines which are parallel to a given line are parallel to each other. Like I said, line 1 is parallel to 2, okay, and line 1 is parallel to 3, then line 2 is also parallel to 3. So it's something like that. Okay, the sum of three interior angles of a triangle is 180 degree. It should be interior angle. Okay, is 180 degree. If a side of a triangle is produced means extended here, the exterior angle so formed is equal to the sum of two interior and opposite angles. Just now we proved it, isn't it? So similarly, let us go through summary of chapter 7. Let us see whether we have covered. So in this chapter you have studied following point. Two figures are congruent if they are same shape and same size. Same shape means angles are same. Okay, similar angle, corresponding angles should be same, and the size also has to be same. Sides has to be same. Sometime I want to say some word, but that is, I do not know, that is my problem, biological problem. Okay, two circles of the same radius, okay, if there are two circles having same radius, are congruent. Okay, they will be same because they are same radius, so they are exactly same. So anything which are exactly same, they are congruent. Two square with exactly same sides are congruent. Okay, and if two triangle ABC and PQ are congruent under the correspondence, that is A corresponds to P and B corresponds to Q or C corresponds to R, then symbolically it is expressed as triangle ABC is congruent to, this is the symbol, congruent to triangle PQR. If two sides and the included angle of one triangle are equal, okay, two sides and the included, that is side, angle, side. Okay, this is side, angle, side congruence. And if two angles and included side, okay, angle, side, angle. So this is angle, side, angle congruence. That also we have done. If two angles and one side of a triangle, okay, two angles and one side of a triangle equal, so that is angle, angle, side. Okay, one angle, then another angle and side. Okay, this is called, which we have also covered. Angle opposite to equal sides of a triangle are equal. Okay, so all the sides are equal to angle opposite. So this is equilateral triangle. So similarly, sides opposite to equal angle of a triangles are equal. Each angle of an equilateral triangle is of 60 degree, we have proved. Okay, all angles are same. Sum of all the interior angle 180. So all angle, three angles. So 180 divided by 3 is 60. If three sides of one triangle are equal and three sides of the other triangle, then the two triangles are congruent. This is SSS. Okay, if three sides of one triangle is equal to three sides of the other triangle, then it is congruent through SSS. If two right triangle if in two right triangle, that is two right angle triangle, the hypotenuse of both the triangle and one side of the triangle are equal, okay, for both the triangle are equal, then you get this right angle, both the hypotenuse and both one side of both the triangle, one side are congruent, then are same, then you say the triangles are congruent by RHS rule. In a triangle, angle opposite to longer side is larger, so which we have shown. Angle opposite to longer, the longer side, the angle opposite to that will be larger. And in a triangle, side opposite to a larger angle or greater angle is longer, the vice versa. Okay, this opposite angle will be larger if the opposite side is large, okay, or opposite side is large if the opposite angle is large. Sum of any two sides of a triangle is greater than the third side. This also we have proved. Suppose we have side A, side B and side C. So side A plus B will always be greater than side C. Okay, or side C is always less than side A plus B if you sum them. That also we have seen. So far we have covered chapter 6 and chapter 7. We have summarized the summary from your textbook, NCERT 9th standard textbook. So this lecture here I will finish, and thank you. See you in the next lecture.